very important thing. First of that is adjacent vertices. What is an adjacent vertex? Basically, by definition, the vertices connected by one edge. So, in this graph, A, B, C, AB is adjacent, BC is adjacent. So, very simple, right? Now, second thing that we have to understand is called degree. And this is, I can tell you, in graph theory, the most important topic. And from these, many things can be solved. Okay, so let's see what this degree is. So we will talk about degree. What is degree? Well, what is degree is a separate question. Whose degree can be there? Of a graph or of an edge? No, of a vertex. So suppose there is a graph, something like this. Okay, name it V1, V2, V3. Okay, and here E1, E2. So degree can be of vertices. So the degree can be of vertices. Say V1. What is the degree of V1 if somebody asks you? Well, the definition of degree is the number of edges incidenting on it and the number of loop into 2. I mean to say, let's don't talk about the last part that I said, twice loop. That part you just ignore. Just think about the first part that I told you in the definition, the number of edges incidenting on a vertex. Okay, so in this case, how many edges are incidenting on V1? Just one, right? This E1. So the degree of V1 will be 1. Simple, very simple. Now what is the degree of V2? Here 1 and here 2. 2 edges are incidenting, right? So that is why it will be 2. What will be the degree of V3? It's simple, only 1, correct? Now come to the second part of the definition that I told you. Loop incident edge into 2, something I said like that. Well, okay, it's not very good in English terms of a definition, but okay, you will understand from the example. Say in this graph only I had a loop like this. Okay, in that case, see, the V3 degree will be same, number of edges 1. V2 will be same, number of edges 2. For V1, it will change. Why? Because earlier it has 1, now I have incidented a loop. So for loop, how many times it incidents on the vertex? 2, twice, and that is why in the definition I told into 2. Okay, so it will be right now 3. Okay, so this is vertex is. This is degree is. Now, from this degree, there is a theorem. So let's name it theorem 1. And I can tell you, most of the graph theory problem statements are on the basis of this theorem. What is this theorem is telling us? The theorem is telling the sum of all the degrees of vertices, say Vi, where I is 0 to n. So basically the sum of all the vertices degree is equals to number of edges. So basically there is a relation between this summation of degree and number of edges. And the relation I am writing is basically this. Okay. So basically this sum of all the degrees will be exactly twice of the number of edges in the graph. Let's see or prove it from this example. Let's see whether it is satisfying or not. Degree 3, degree 2, degree 1. So sum of them is 6 equals to 2 into number of edges. So number of edges is equals to 3. Is it? See, E1, E2 and these I can consider E3. 3 edges. So this formula This theorem is a very important theorem of graph theory. From here, we will come to next theorem. We will talk about the next theorem, theorem number 2. The theorem number 2 is saying, I will write down, the number of vertices with odd degree are even in number. Okay, I repeat, the vertices with odd degree, the number of vertices with odd degree are even in number. Is it? Let's see from the example. Suppose there is a graph with say v1, v2, v3. Okay, and let's compute the degrees of them. So degree of v1, 1, right? Only one edge. Degree of v2, here 2 edges, 2. Degree of v3, 1. So you can count, right? How many odd degree vertices are there? One here and another here. What is the count total? 2. So is this a even number? Yes. So in this way you can go ahead, like you just add another vertex like this, v4. Okay, now what happens? v1 degree remains same, v2 degree changes, right? 1, 2, 3. So it changes. v3 degree remains same. Now degree of v4. Okay, this v4, 1. Now see, this 1, this 3, this 1, this 1. Now the count has become 4. Is it even number? Yes. So this is how you can move ahead, add vertices, edges, whatever you can check. So this is what this theorem is talking about.